So good morning, everyone, and I'm so happy to be here because this is our first event officially as CESMII, and we got started yesterday, and so really appreciate the time you've taken to learn more about what CESMII is about. And what I want to share with you today is what is smart manufacturing about for Corning, and CESMII will play an important role in that. The SMLC has played a very vital role in smart manufacturing becoming a part of Corning's direction and vision and strategy. And what I'd like to first start out and say is that smart manufacturing needs to be what your company needs it to be. You need to be solving business problems and adding value. And so it's a journey, no matter where you are in that journey. What I have found is that we can learn from each other, and this collaborative environment that CESMII creates for us to do that will, I'm sure, most certainly be a benefit to your organization. And another thing that I'd like to say is that this is not about judging, right? We're all at different places, as I already mentioned, and so this is where we are, and I'll tell you more about what it means for Corning. So just a brief history about Corning Incorporated for those that aren't familiar with it. Yes, Corning did make Corelware and Visionsware, things that the consumer was very familiar with, but we no longer make that. We have sold that, but Corelware, for example, is still manufactured in Corning, New York, where Corning is located. It was founded in 1851, and we're a 166-year-old company. And as you can see there, we're a Fortune 500 company, and there aren't a lot of companies that are in the Fortune 500 that have survived for 166 years. But the reason Corning believes it has survived is because of its innovation. And smart manufacturing is a part of its innovation, and I'll tell you more about that. We pride ourselves in research and development and then delivering products with attributes that are difficult to accomplish, and you'll see more about that in my project too. We work in essentially 5 segments and some additional ones where we're working on new innovations, but we work in display technology, so for those of you that have mobile devices, a really good chance that it has our Gorilla Glass on it. We are the market leader in strengthened glass for mobile applications. We also work on display glass for flat screen televisions as well. We also invented the optical fiber for telecommunications, and that's a big part of how all of these devices that you all are looking at right now and carry around with you get the information that it's providing. We also have a wireless technology which allows you to utilize these mobile devices and get that into the fiber network so that you have the bandwidth when you have multiple users of wireless technology. On the ceramic side, we make what we call cellular ceramics. They go into diesel particulate filters and into catalytic converters for automobiles. And this is one of the products that is made in Corning, New York also, as well as around the world. Life sciences, we do some, as you can see there in the picture, we do some injection molding, and we also have glass products that we make for the life sciences industry. I mentioned specialty materials already when I mentioned Gorilla Glass, and then some new innovations that we're working on. So as I mentioned, innovation is part of how we've survived 166 years. And this is, an example of some of the innovations. It goes all the way back to Thomas Edison coming to Corning and say, can you make me a glass envelope for an incandescent bulb? And Corning provided that for him. And if you kind of look through the history, Pyrex, back when we had the large televisions that were made with cathode ray tubes, Corning made the glass for both the screen and the back side of that, which is a picture there. I already mentioned fiber, the glass ceramics, And some of our newer technologies are things like bendable fiber. For anyone that has worked with fiber, you know if you bend it too far, the bending losses essentially extinguish the signal. But when you're installing in on-premise, like apartment buildings, office buildings, you need to be able to turn tight corners, and our bendable fiber allows that to happen with no loss. And then you can see some of the things of the future around, first EPA antimicrobial cover glass and very flexible glass for things like wearables and maybe even electronic newspapers that roll up and roll out, just things of the future. So Corning's always looking ahead at what will be the things that make our lives, I'll say, more enriched in the future, and how Corning can contribute to that. Okay, so as I mentioned already, Corning's strategic approach is deeply rooted in innovation of both products and processes, and today I'll talk about some of that. Our sales are enabled by producing quality products with the attributes that our customers want at the right price. And if it's not at the right price and it's not what the customer wants, then you have no sales. Our profitability is also achieved through supply chain management and manufacturing excellence. And so as a combination of an organization all working together, bringing our expertises, we are a world-class manufacturer of specialty materials, and smart manufacturing is going to help us continue that legacy. So today I'm going to talk about knowing smart, working smart, our test bed that we're working smart, playing smart, and that's about how we engage with one another in a collaborative way, and have a few minutes for questions and answers. But I listed some things here because it's important to think about what's going on around your company, and I mean outside your company. Because there, as you see here, we hear about big data, we hear about IoT, and you hear about smart manufacturing because as an organization, the SMLC and its collaborators have made it something that is going to bring value. But what does this mean about what our customers and our suppliers are going to expect as we are manufacturers in the supply chain? How does this change our expectations? So if you think about today in your personal life, you essentially can get online, you can search for whatever you want, you have choices, you get to look at them quickly, you can place an order and reasonably expect something to show up within a couple days. How does that change your expectations in your work world about how things should operate? And I think that's what we as manufacturers need to be thinking about, because what's happening in a consumer world is going to need to be adapted and be available in the manufacturing world, because we expect it, and we are the workers in the manufacturing world. So when I talk about knowing smart, I'll just give you a little bit of definition. And for those that have been thinking about this for a while, you've been hearing about the next industrial revolution and the cyber-physical systems, and many countries have initiatives to really make sure that their manufacturing is competitive in the future. And the SMLC and the Department of Energy have partnered to make U.S. manufacturing competitive. And so this is something that we need to, it's a global economy. We need to realize that this is happening around the world, and if we pretend it's not because we're not there, we will get left behind. So I really liked what Haresh from Alcoa said. He said, this is about getting the right data to the right people or machines at the right time to make the right decisions. And that's fundamentally what we're driving to do. So all of us deeply depend upon data, and we get that data through our information technology systems, and we deliver our business objectives with that information. And smart manufacturing is really redefining all of these areas. So for Corning, smart manufacturing is about integrating cloud computing so that we have more computational capability, we have more data storage capability, and having the security so that we don't make our assets vulnerable and our intellectual property accessible is really important in this. We're really looking to drive things around advanced analytics, predictive modeling, advanced controls. We do a lot of work already today in sensors, controls, And so we're really looking at how do we better integrate these things to accomplish the next level of performance. And when you think about what's going on in our universities, there are things that they've been working on for a few years that now can become real for us in the manufacturing world. They're maturing. And so we really look for our academic partners to help us identify what are things that now that we have the technologies available that are now really viable manufacturing options. And so that'll be an important part that we work together on in this collaboration. There are new visualization tools. There are new visualization technologies. And how is that going to change the worker and how the worker does their job? And ultimately, we got to reduce costs because we've got to be competitive. Key way of doing that is reducing our energy consumption, and it's being responsible stewards of our planet as well. But these collaborative business models, if you think about it, it's a trend. If you think about crowdsourcing, if you think about hackathons, these are things that are going on. And this collaborative model that CESMII is creating is a form of this new way of doing work. Today we have our integrated manufacturing systems, and you all know there's tons of capability, and they're all individual applications. They all perform their function, and we've had to put a lot of effort into having them work interoperably with one another. And really, they're not very interoperable unless there's a tremendous amount of maintenance preserving that interoperability. So smart manufacturing really is going to help us drive interoperable solutions that we can more efficiently integrate the old legacy technology with these future technologies and take our manufacturing to the next level. So, one thing that I know other companies are doing, and as I said, this is a journey, so different companies are in different places. But if you think about these integrated manufacturing systems, each plant in the supply chain has their own, and they're not the same, and that's a misnomer of this diagram. They all look the same, but in reality, they're not. And so how do you create these connected supply chains where your supplier can share information with you and you can share information with your customer, and ultimately the chain of manufacturing that product is more efficient, we produce higher quality products, and ultimately at a lower cost because we're helping each other do it. And so this connectivity of our operational technologies, the OT systems, and our IT systems, our information technology systems, being able to share data more seamlessly is going to create tremendous value for our businesses. And so being able to share your product and contextual data with your customer creates new value streams. So in Corning, we define smart manufacturing to be the concept of combining multiple capabilities, that's integrating measurements, controls, computing platforms, modeling, analytics, to improve process and product development, manufacturing performance, and reduce manufacturing cost within a plant and across the supply chain. And this is about the efficiency of how you accomplish making product. It's lower waste, it's higher productivity of energy. And for Corning, when do we need smart manufacturing? Well, we're making products that have a lot of data, and we today don't harvest the information such that we get maximum value out of that data. And so we're really looking at how do we leverage our data better to better run, control, and optimize our processes. And when there's an opportunity to create profitability from sharing data, so how can my supplier help me? If I had this information from them, then I would be able to run my factory more efficiently. If I supply this data to my customer, then they'd be able to run their factory more efficiently. And so if you think about these connected supply chains, there's real profitability opportunities here. We also have a program called Product Quality Architecture in Corning, and this is about knowing what defines quality for the customer. And I'm going to talk a lot about this in our project that I review with you. And confirming the ability to be able to measure what's important to them, being able to make sure that you only send product that conforms to what they're expecting to receive, and then going the next level. I want to know what drives those key process output variables, which are what defines quality for the customer. And those key process input variables that drive the performance of the key process output variables that matter require context in order to understand that. And so having time series data matched up with your discrete data is really important, because when you're running experiments, when you're analyzing your data, you need to know how this data relates to all the other data that you've collected. And when you can do that, then you can essentially generate more knowledge in your organization, and then you can improve the process and work on the next problem that needs to be solved. But reducing scrap, reducing rework, all means that you're reducing energy. And so yesterday, we talked about the collateral benefits of smart manufacturing. If we are more productive in our manufacturing, we are lower consumers of energy. And that's what DOE wants us to be. And we want to be, right? We want this earth to be habitable for many years to come. So how do we work smart in Corning? We did our first smart manufacturing test bed. We got started in July of last year. And so let me just tell you a little bit about that. This test bed is on a product that Corning's working on in a process. And just for simple understanding, we have glass that comes into this process, and we do some manipulation of that glass, and then it goes to another process step, and we do some additional manipulation of the glass, and then we have a final inspection. Well, the problem is that that first process doesn't have an inspection, doesn't have a measurement, doesn't have a way for me to monitor how is process number one performing. And we are working on sensors to do that, but we don't have it yet. And what we need to do is really challenging. So we're looking at, we have a final inspection that has the throughput capability for manufacturing. So how do we leverage monitoring those key process input variables from each of the processes, monitoring what we can in terms of the in-process measurements for each of those processes, and building a model that says, when I run my processes in this way, this is when I produce product that meets the customer's expectations. And so we've got to build modeling to essentially be able to have a controllable process, have a high-yielding process, and as you can see here, it may even involve a manufacturing strategy that this product isn't completed under one roof. It may be completed in two separate locations. And so now this is where cyber-physical systems start to close that gap between locations, so that we can take a decoupled process in the physical world and make it coupled in the digital world. So just for illustration purposes, talking basketball. We have something that we call integrated process design and for process control, and this is something that's in literature. But what you need to do is you need to get the subject matter experts together across the organization, and you need to identify what defines critical to quality attributes. In this case, it would be free throws made, not free throws missed. And you need to have each of the materials, process area, controls, measurements people come together and say, for those CTQs, what are the key process input variables that drive the performance of them? And the more mature your manufacturing is, the more that this chart is filled out and you know. The earlier you are in your process life cycle, the unknowns are a lot greater. And so what you do is you say there's as I say, there's 100 things that can be measured, but you don't have the money to measure all 100. So where do you get started? And so you leverage that subject matter expertise to prioritize and say, this is what we believe based on our education, based on our experience, based on the data we have so far, are the key process input variables that we need to monitor. And you do your design of experiments and you understand how much of the variation am I explaining based on what I can measure. But when you start thinking about critical to quality, even in research and development, it gets the team focused on the game that you're playing and what defines success. And that's really important because now people are working on a common goal. Instead of, well, I'm trying to improve this, well, I'm trying to improve that. We all have to be working in concert with one another to improve each of them in an organized way. And so through the, I'll say about 4 months of 2016, we added several measurements. We added measurements that went from only being able to measure 15% of the attributes to being able to measure 100% of the attributes. And for those that have worked in I'll say processing and processes, averages can tell you something, but there's a lot they don't tell you. Standard deviations tell you something, but there's a lot they don't tell you. So for example, in the top left corner, there are essentially, there's a map of where are my averages higher and where are my averages lower. And this starts to be really critical information when you're trying to understand what's driving performance of my process. And when you have the data, then you can look at it in ways that tell you more. And you learn that, hey, actually, I need more sensors in this process in order to be able to characterize what's going on in the process, because one sensor doesn't tell me what's happening in terms of this map that you see in the top left corner. And then you go back to first principles, you design models that represent what you're doing, you validate those models with the data you're getting, and you essentially write your equations that define your process behavior. Oops. So with taking this approach of getting everyone focused on the goal and having appropriate sensors, having the data systems to support their learning from those sensors, we were able to drive our attributes to improvement in just 4 short months. And actually, it was less than that. It was probably more like 2.5. What does this mean? This means that the team was able to focus, improve the process, and we know that we're not quite there yet. In early stage, there's a lot of times the customer can't tell you what the spec is. And I call it drawing the line in the sand. You got to start someplace. You got to start shooting for something. And when you start shooting for something, you can get the team to focus to improve. And the reason it's a line in the sand is it's our best knowledge based on working with the customer, based on understanding what the customer's trying to do. And if you didn't guess right, nice thing about drawing a line in the sand is you can wipe that line out and redraw it based on new information and new knowledge. And this is a really important aspect to being able to improve performance when there's a lot of ambiguity. So what does the team tell us, though? Well, we were able to do a lot more than we could before smart manufacturing got started, but we need more computing capability, we need more data storage capability, because the size of these data sets far exceeds what they can do in Excel, what they can do in JUMP. They need tools that allow them to do big data analysis. And they need to move to factorial experiments, and that analysis needs to be able to access lots of data. It's not something you can do hand-o-matic. So, we need these connected data streams. And for Corning, we're going to have our first cloud for manufacturing and a connected supply chain in 2017. We use cloud technology on the business side, but for manufacturing, there's a lot of reasons that it hasn't been done yet. Part of it is it's being developed. Part of it is those are our crown jewels you're putting out in the cloud, and the sensitivity of that is very high. So we're really looking forward to being able to bridge this capability gap that currently exists through our work with CESMII. And this data looks straightforward. You say, well, this is just good process engineering. But the fact of the matter is that the data is so large that we can't use our good process engineering techniques of today in order to accomplish this process. So we're moving from gigabytes of data to terabytes of data per step, per piece. The data's complex. There's strong interactions between the processes. And we need to preserve the context, but we've got batch data, we got continuous data, we got multiple site data. And so now you start to get a feel for this isn't something our systems of today handles very well. And we need to bridge that gap of Corning factory versus a non-Corning factory. We are going to have to make business commitments and build business relationships that are different than we do today. Sharing data is not something that our supply chain is used to doing. And we have to recognize the greater value that exists when we partner more than we do today, because I'm not going to drive your costs down because you're sharing information about what you're sending me. And I don't mean your costs. I'm not going to drive the price I'm willing to pay down because you're sharing data about what you're sending to me. And our suppliers need to be willing to do the same. This needs to be new business agreements that, at least for Corning, will be groundbreaking, and those will take some time in order to establish. And as I said, this can't be done with our legacy systems. So our team, and Dave Kuhn is here today with me, has been thinking about how do we bridge historical technology with bringing this capability of the future, particularly around cloud computing. And I think the most, actually I'd say the example that Jim Davis gave about riding a bike, then building a scooter, I should say building a bike, building a scooter, building a motorcycle, building, maybe it's a golf cart. It's got 4 wheels now. Building an automobile, building a truck. This is a really good analogy because this process, this product needs something now. But I can't give them the Cadillac now because the Cadillac hasn't been built. We're still in the bicycle phase. And so giving them a bicycle and having a plan to get from a bicycle to a scooter to a motorcycle to a car is how we are accomplishing giving them value today on a trajectory that gets us to where we know we need to be in the future. And for Corning, smart manufacturing is going to need to leverage what we call cloud and edge computing capability. Our data sets are too big to be sending all of that up to the cloud. The network costs for doing that will be too high. And so we're going to have a hybrid of having on-prem cloud capability and off-prem cloud capability. And that cloud-to-cloud communication, even within our business, is going to be important. So, top right-hand side of the slides, I had some disciplines that were coming together to make each of those slides possible. And what we're finding in Corning is that we have to play smart. And playing smart means collaborative partnerships. And we are breaking down organizational barriers within the company that are decades old. We still have controls, measurements, process, statistics, quality, so on and so forth in their silos. But we are making those organizations work together on common goals. And I think playing smart is also how we as industry members, as academic members, as public sector members, make this really happen. So in Corning, successful execution has been demonstrated with a multi-organization commitment to a common vision and shared goals. And the keys to our success are the partnerships across these organizational boundaries, and they're also collaboration amongst these multidisciplinary teams. And for those that have done any sort of systems engineering type work, it's about trade-offs. We all have a common goal. We all want our job to be easy. But sometimes I have to do a harder job because I realize my colleague can't get there if I don't do something that makes it easier for them. And so having that common goal about what we're trying to achieve and how collectively we're going to get there has been really our enabling feature here. And so we have businesses coming together. We have initiatives and programs in Corning coming together. And we have subject matter experts and domain expertise coming together, working on a common goal for this project that I showed you under a project manager, Smart Manufacturing Project Manager. And that project manager's objective is to make sure that we are solving business problems using smart technology, because that's how they're going to go, that's how they're going to be successful. And so how do we do this across multiple organizations outside of Corning? So I've talked with Jim Wetzel. He's a little farther along than Corning, well, actually quite a bit farther along than Corning, on their smart manufacturing journey. Larry Negan is farther along than Corning as well. And so already through the Smart Manufacturing Leadership Coalition, I'm learning from them. They're building capability that will be shared capability. And that shared capability now means that what Corning's actually working on is only a fragment of how the capability is being built. And so as we pursue driving energy productivity up, making US manufacturing more competitive, having the workforce to do this kind of work, we together have a much larger portfolio than any one company alone. And so this is about playing smart within your company and playing smart outside of your company using collaborative models. And the different colors of text here have some real meaning. For Corning, the things that have yellow text actually bring value to I'll say things that Praxair did bring value to Corning. Things that General Mills is working on bring value to Corning. And I'm sure the corollaries are there as well. And as we work in CESMII, there's IP procedures, and there are even opportunities to generate revenue for entities. So as I say, know smart, work smart, play smart, and I think it's a smart plan. Because the Smart Manufacturing Leadership Coalition has set the stage for this collaborative environment, for this way of accomplishing, leveraging modeling, analytics, more sensors, more process control to make US manufacturing more competitive. And we are now working in a collaborative agreement with Department of Energy to make sure that what we're doing is creating jobs for the US, driving energy costs down, driving energy productivity up, and working across the public-private partnerships that you all represent to do it. And so as I see it, and this isn't all of the benefits, but for Corning, some of the benefits I see. We quickly build knowledge to look at smart manufacturing and energy productivity through your eyes gives me ideas about how I do it for Corning to solve Corning's business needs. And I think that's something that for those that have been a part of the SMLC, they've already experienced that. But for those of you that are considering CESMII, just think about how much faster you could go if you got to think outside of the box that your day-to-day work puts you in. It's about training. One of the things that we're working on right now is, well, we don't have the resources to do these technologies in Corning. Where can we get them? How do we bring this workforce that exists today up to the level of being able to do these new technologies and being a part of that workforce training plan? Because we see the gaps already. And working with academia to help us bring these new technologies that are manufacturing, I'll say ready to us as a US manufacturer. And how do we develop the students that are coming out of schools to be ready to help us solve these problems? It's not in their curriculum today to do this kind of work. So this is the partnership that we will be creating to not only take technology to the next level, but to bring the workforce to the next level. The other value that we see is the branding of smart manufacturing. Having SM solutions, I'll call them, whether it's SM certified suppliers, SM certified resources, the marketplace, SM certified products. As a consumer, I know that that means it's compatible. I know they speak the language. They have the know-how to work smart. And I think that's a real value, because as we're starting this journey, that resource pool, that product supply chain is not there yet. Being vendor agnostic, designs allows us to integrate our legacy technologies with the new technologies, and it gives us choice. In Corning, we call them building blocks. If we build functionality and we can bring these building blocks to work together, independent of which company produced them, there's real power there, because what I need is not exactly what Jim Wetzel needs, is not exactly what Larry Megan needs. But having building blocks, we can put them together in ways that we can accomplish each of our needs without having to reinvent and redevelop each time. And that's the test bed reuse application that Jim Davis talked about. And then developing these strategic relationships, just being able to talk with people about, so I have this problem in Corning. Do you all have that problem? How did you overcome it since you don't? For example, just like organizing. Are you changing the way you're organizing in order to successfully do this? Meaning within your company and your organization design. And then, access to IP, and sharing our non-proprietary solution content. There are things that Corning's developing that will be available to you all. There are things that we won't share, like I won't share our fishbone diagram, because that's crown jewels about how we make what we make. But I'll share with you that we're using fishbone diagrams so that you can apply it to your business. And then, really enabling US manufacturing. We live here. We want this to be a place that we all want to live and prosper. And so investing in the US is a smart thing to do. We also, not all of us, but I work for an international company. So I also need to figure out, how do I make smart manufacturing be a part of Corning while we're a global manufacturer too? Because it's not cost effective for me to have two organizations that do two totally different things. So that's something that together we'll figure out how to do.